1.8 two-set Venn diagrams. So let's talk about reading Venn diagrams. The following Venn diagram represents the number of grade 12 students at Mathville High School who play baseball and basketball. State the value of the following using proper notation. Okay, so if baseball is, like the word baseball is located above this circle, then we're going to assume that that circle represents the students who play baseball. And then we have basketball here, so likewise, that's going to be the circle who represents the set of individuals who play basketball. So, number one, the number of students who play baseball. So we can just say number of baseball. That is going to be everybody in that entire circle, which is 41 plus the 12. So we get 53. And for number two, the number of people who like basketball. Okay, we're going to get that 12 plus the 23, and we're going to get it 35. Okay, B, the number of students who play baseball and basketball. So as soon as we see this word here, we're going to go the number of base, and we're going to use that N, the intersection, and basket. And we're going to go ahead and short form that. So baseball and basketball is going to be this overlap right here. That's going to be 12. Okay, whereas the number of students who play baseball or basketball, we're going to use the union because it's either or. Remember how it's going to be a little bit fluffy, like as long as they play one or the other. So we get 41 plus 12 plus 23. Because all of these individuals play either baseball or basketball or even both of them. Okay, so 3, 4, 5, 6. So I get 76. Now, the number of students who play neither baseball nor basketball. So not baseball, not basketball. Okay, so this is going to technically be baseball or basketball. Complement. So just not baseball or basketball. And that's going to be this outside number 4. So those individuals are still in the universal set because they're still in this entire box here. So they were surveyed. They just don't fit into baseball or basketball players. We still have to account for them though. So the total number of individuals who were surveyed. We're going to add up every single number inside of this box. Remember, this is going to be the total number in the universal set. So 41 plus 12 plus 23 plus 4, I get 80. 80 individuals were surveyed. Another way of writing this is the number in the universal set. Okay? Now, the number of players who play one sport. And I'm just going to write that as one sport. So we can specifically look at this Venn diagram and we say these individuals play 2 sports, so we're not talking about that. These individuals do not play either baseball or basketball. By one sport, of course, the assumption is either baseball or basketball. We're going to add 41 plus 23 because this 41 takes into account only this area here, and this 23 takes into account this area here, but it's not going in the intersection. So this is going to be 41 plus 23. So it's going to be 64 people play one sport. Okay. So let's go ahead and create a Venn diagram for these sets. So the universal set is 1 to 10, and that's going to be the entire box. So let's go ahead and fill in set A. We'll label this circle A, this circle B. Okay. What we want to do is we want to go inside out. Okay, so inside would be, first we're going to fill in this intersection. So both of these have a 2, both of them have a 4, and both of them have a 6. So 2, 4, 6. And this is a different way of representing a Venn diagram. Okay, the way above here was that we represented the total number of people in each set. Now we're actually listing the elements. And so in set A, we've already taken into account 2, 4, 6. The ones that are left are 1, 3, and 5. And in set B, the numbers that are left are 8 and 10. And then we want to just go through all of the numbers from 1 to 10, universal set, and anything that didn't fit into set A or set B, we're going to put in the box but outside of those circles. So 1, 2, 3, 4, 5, 6 are already taken into account. 7 didn't fit, so let's write 7 outside. 8 fit, and then we need a 9, so we'll write it there. Okay, and that's how we create a Venn diagram for the sets. Now, let's read this Venn diagram, okay? Determine the elements in each of the following sets. So in set A, we want, remember this is A, so it's going to be 2, 4, 6, 8. Okay, so this is going to be 2, 4, 6, 8. And everything in A complement. What would actually be easier is if we wrote down every element in the universal set, and let's write them in order. So I get 1, 2, 3, 4, 5, 6, 7, 8 would be the universal set. So everything not in A, what we would do essentially is we can do this visually, like these are not in A and these are not in A, or we can go to the universal set and say, okay, in A we have 2, 4, 6, and 8, and we can list all of the numbers that are not 2, 4, 6, and 8. So 1, 3, 5, 7. Okay, so let's go ahead and write 1, 3, 5, 7. Now B is going to be this set here. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. And I'm just doing them in order. So not B is going to be the 8 and the 5 and 7. So 5, 7, 8 in order. Okay. A or B is going to be anything in A or B. So everything in here. I get 1, 2, 3, 4, 6, 8. And what about not in A or B? Well, it's going to be the 5 and the 7. It's going to be the leftovers. Now, A and B, we're going to focus on this intersection, 2, 4, and 6. And then for not in A and B, we're going to list everything else. So 1, 3, 5, 7, 8. 1, 3, 5, 7, 8. Okay? And then for the last one, we already listed the universal set. The number in the universal set is 8. Remember, this n is looking for an integer value. Okay, let's talk about common elements. So there are 12 students on a soccer team and 16 on a baseball team. Okay, so soccer is 12, baseball is 16. When planning a tournament with both teams, the coach must arrange transportation for a total of 20 students. Okay, so total is going to be 20. Use a Venn diagram to illustrate this situation. And just note, you must solve for the number of common elements using a variable. Okay, so here's the thing. We know that this entire box is going to be the universal set, so it's going to have a total of 20 individuals. Let's name this soccer and this baseball. And just be aware that sometimes when we have like soccer and we are using a capital S for the event, that you might immediately be thinking universal set, but just be careful of that. Okay, so we know that this circle here is going to have a total of 12 individuals. The thing is, we don't know how many are on both teams. Because if you think about it, 12 plus 16 is not 20. Right? It's 28. So somehow we've double counted. And somehow it's reflecting that there's 8 extra people, but there's not. So for this 12, it's going to be 12 minus x. And now this B, we already took into account x, but the baseball players is going to be 16 minus x. So the thing is, 12 minus x plus 16 minus x is going to be us adding all three of these numbers, and we know that those are going to add to 20. Now, minus x plus x can cancel out because one's positive, one's negative. What is 12 plus 16? We said that that was 28. Minus x equals 20. Let's go ahead and bring this 20 over. We'll bring that negative x over, and we get x equals 28 minus 20. We get x equals 8. There we go. Okay, so let's go ahead and plot that right in the middle. That's going to be 8. Thing is, this was originally 12 minus x, which is actually 12 minus 8. So the number in this circle should be 4. Okay, so 4 individuals only play soccer. 8 play both soccer and baseball. And then this one was originally 16 minus x. So if we get rid of the 8 from the middle that we already counted, we should get 8. And if you think about checking, 4 plus 8 plus 8 equals 20. So if we're thinking universal set for the entire box is 20. Okay, so we've determined the number of students in the remaining regions of the diagram and explain what these regions represent. So let's put a little arrow. This 4 represents students who only play soccer. Students who only play soccer. Okay, this 8 represents students who only play baseball. And then this middle one represents students who play soccer and baseball. Okay, so here's our explanation to C. Explain why you cannot just add the number of students who play soccer and the number of students who play baseball to find the total number of students on the teams. We already tried that. We already saw that it does not equal 20, but we know that there's 20 across both teams. So let's write a quick explanation just saying we cannot just add because, so we cannot just add because some players play on both teams. Okay, leaving us to double count. Okay, we're double counting those individuals. That's why if you think about it logically, 20 and 28, that would be 28, right? 20, 28, the difference was 8. Well, these middle people, we double counted those 8 individuals. Okay? Now let's specifically talk about non-mutually exclusive events. So that's when different events happen at the same time. Okay, we already kind of like walked through this in an informal way, where for sets A and B, the total number in either A or B, and remember that's that fluff where we add up everything as long as you fall into one, okay, is the number in A, which is this one, plus the number in B. Here's the issue. When we did A, we counted in here. When we did B, we counted in here. So we double counted that middle. What ends up happening now is that we have to subtract just that middle portion one time to get rid of the double counting. So this is formally called the principle of inclusion and exclusion for 2 sets. So number in A or B is going to be number in A plus number in B. We're going to subtract that intersection. It's exactly what we just did. We just did it the long way. So let's go ahead and use that formula in the next question. So a drama club is putting on 2 plays. There are 11 actors in the first play. Okay, 15 actors in the second play. Maybe I should put the number in the first play, number in the second play. Okay, and 3 actors in both plays. So the number in the first and the second, so that intersection is 3. So use a Venn diagram to organize the data and then to determine the total number of actors between the two plays. Okay? So what that's asking for is first or second play. So this is going to be the first play. This is going to be the second play. And we know that we go inside out. Okay? So remember inside out. And we already talked about that. So this 3 is going to go in that intersection. Now in the first play, we had 11 people, but we already counted 3. So that leaves us with 8 individuals only in the first play, 3 in both. And then in the second play, we had 15 minus the 3 for the double count, and we get 12. So 12 specifically only in the second play. Now, we can do that using a Venn diagram, or for B, what we can do is we can use the principle of inclusion and exclusion, okay? And we're gonna then compare our results. So the number in the first or the second, so that's kind of like saying the total in both of those circles, is going to be the number in the first plus the number in the second minus the number in the first and second. Okay, so we get 11 plus 15, but we know we've done double counted, so we have to subtract what's in the middle, which is that double counting. So we can see that the total number of people is 23 across both plays. Well, if we take a look at this one and we did 8 plus 3 plus 12, we also get 23. So when comparing these, this is the same number. Okay, so this is just illustrating that we can do this using the equation, or we can illustrate this using Venn diagrams.